What is walkability in a city? Walkability is a new term to describe how friendly a city or a neighborhood is for pedestrian activity. The Masdar Master Plan claims a walkable and connected grid system. Our project looks to challenge their claim and further reimagine the traditional grid system into something truly optimized for walkability. We will quantify this with consideration for the existing amenities, such as transport nodes and green spaces, as a focus for design evolutions. The master plan claims that everywhere in Masdar is at most 150 meters from the nearest transport node. Although true, this claim doesn't reflect the walkability when viewed in the context of the city's existing spatial layout. This model calculates the shortest walking distances from every building to the nearest transport node, showing a significant increase in average and maximum distances compared with the 150 meters. Allowing movement of these nodes, we can seek to improve these results and optimize the equality of access to the transport system. Showing here the cells served by each node. The optimization finds a reduction in results but still not within the proclaimed 150 meters. The concept of calculating walkability can be adapted for further design principles such as green space coverage. This model uses multi-objective optimization, seeking a given green coverage, in this case, 25%, whilst minimizing the average and standard deviation of walkable distances between buildings and green space. Thus, optimizing green access in an urban environment. Here results are shown when testing for different green space coverages, 5, 10, 50 and 75%, showing the effectiveness of this model at a range of scales. Reflecting on the testing of Masdar, we seek to develop a truly organic street network design, one that will rival Masdar's rigid master plan. To achieve something organic, we must allow the design to evolve as it sees fit, conforming itself to optimal fitness. This is enabled through the parametricism of our network. The network is designed using point-to-point lines and cellular division. We begin with a road cutting through the site. Then adding further dividers, allowing each freedom of movement. Each generational line is free to start anywhere on the bounding curves, although there is control over the endpoint, for 1. Preventing streets from beginning and ending on the same edge. And 2. Preventing null or short lines, when the street begins in, or near a corner. This is reapplied recursively to the sections formed between lines, following the same rules as the major roads. The only additional control is the subdivision is only applied to sections that don't have an area below a control percentage of the total area. Once all blocks have been formed, pathways are added, connecting centroids with direct paths to their bounding edges. Using this parametric network generation, we can apply our green space and transport proximity testing, but this time allowing the network generative freedom of topology. How does this entanglement of lines become a city? How does the walkable city look? Well, let's apply the roads to the Masdar plot. Remove the smallest plots. Add the green space, blocks, pathways, buildable area, and growth. This could be the future of Masdar. This is what a truly walkable city looks like.